Now it's my great pleasure to give the floor to Luca PERSIA, Professor of Sustainable Transport Planning and Director of Research Center for Transport and Logistics at Sapienza University in Rome. Also, he is chairman of Sapienza University startup company CTL-up. I would also like to take this opportunity and to congratulate Professor Luca PERSIA, who has also recently been elected as a president of the Forum of European Road Safety Research Institutes. Luca's areas of expertise include sustainable transport policies, road safety planning, cycling mobility systems, and intelligent transport systems. His today's topic for conference, strategies and actions for a systemic change in urban mobility. Dear Luca, please, the floor is yours.
Thank you, Olga. You are always very kind. And thank you for inviting me to this absolutely interesting event. I'm going to share my presentation. Please tell me whether everything is okay.
Yes, everything is okay.
Good. I'm trying to put it in full screen mode. Okay. So I'll try to say something about the future of urban mobility, which is something not so easy at all due to all the dramatic changes we are living in our mobility systems. So I will try to focus on the concept of evolution and revolution in transport systems and to analyze what are the components of the revolution we are currently living. Trying to highlight the expected impacts on, in general terms of sustainability of transport systems and with a specific focus on road safety. And in the end, I'll try to also to remark the relevance of a balanced approach to sustainable transport planning. So let's start from the concept of evolution. We always have evolutions in all the sectors of our transport systems and also in all the vehicles. Evolution means that there is a gradual change in the vehicles, in the infrastructures, in the services. So, for instance, if we look at some Italian vehicles, on the left, you have the 500 car from Fiat. So, comparing the car, how it was more than 70 years ago to how it is more nowadays. They are all, of course, different, but not so different. The same for the train or for the aircrafts. So it's interesting to see what has been studied by Professor Cascetta in one recent work, where he compared the evolution and the revolution of transport systems. So the evolution is something happening gradually, while revolutions are moments of the history when dramatic innovations led to a significant change on the way people and freight moved. So you can read on the table some revolutions on our history, starting from the animal traction to the sailing, the invention of the wheel, the steam traction, the internal combustion engine, and also the introduction of a new generation way of carrying freights on the sea. For every revolution, then we had a period of evolution. So it's important to look at the history of our revolutions in order to better understand what is happening now. We are living a period of dramatic revolution of the transport system. And Before entering into the details of this revolution, it's probably useful to try to understand why. What are the forces behind the need of such a revolution in our transport systems? Let's try to look at some figures where we are now. So, looking at figures produced by the European Commission in terms of CO2 emission, for instance, we see that nearly 32% of CO2 is produced by transport. The highest source of CO2 is transport, followed by the energy industries and the industries as a whole. And out of all the CO2 produced by transport, we see that nearly 3/4 are produced by road transport, with the remaining. I think there is a microphone opened somewhere. With the remaining part shared by aviation and navigation, and very limited amount produced by railways. Going into the details of road transport, who is the main culprit? Cars. Cars produce nearly 60% of the CO2 produced by the road transport, followed by the heavy duty vehicles and buses and the light duty vehicles. So it is clear also from the picture I included in the slide how unsustainable are our modern mobility systems, and there is an absolute need for changing them dramatically. Even if we look at the situation in terms of road safety, looking at the most recent statistics produced by the WHO, which somehow changed the previous data, which were even worse. But still, we see that at world level, we remain around 1.2 million people dying every year. Even if in the last years there has been a slight reduction. Data which are completely far from the expectations and objectives set by the United Nations at the beginning of every decade, when a reduction of 50% is expected for the decade itself. So there is an absolute need for a revolution of our transport system, and this is something we are living. Differently from the other revolutions we introduced at the beginning of the presentation, in this case we can say that the modern revolution is composed by several elements. So we have from one side the decarbonization of vehicles with a so important introduction of electric mobility. And then we have all the studies, all the research, and also the applications on the autonomous mobility, with the introduction of the connected, cooperative, and automated vehicles. And the third pillar is the smart mobility, and particularly the sharing mobility, which is changing the approach of many people, especially young people, to mobility in terms of use of vehicle instead of ownership. And then we have a fourth element, which can be considered an horizontal element, affecting all the three pillars and also the other sectors of mobility, which is, to my view, probably the most important, and it is the digitalization. So all these elements, the pillars and the horizontal elements, are expected to improve the components of sustainability of transport systems. So it is expected to reduce the congestion, it is expected to reduce the environmental impacts in terms of air quality, so in terms of pollutant emission, and in terms of noise. It is expected to improve also the social element of sustainability in terms of accessibility, so improve the possibility for all people to travel, and in terms of reduction of road accidents, injuries, and fatalities, as well as the improvement of the efficiency of transport system. So let's make a short focus on road safety. How the revolution, the pillars of the revolution, of the current revolution, will affect road safety in the near future. Let's start from electric vehicles. Well, looking at the relationship between electric vehicles and road safety, there are several elements to be taken into account. So first of all, in terms of driving behavior, we all know how fastly electric vehicles accelerate, and this can lead to some problems of risk. There can be also impacts on the driving behavior of users. We have been part of a European project focusing on how users react to such strong innovations, and we all know that the worry for the battery charging can increase the anxiety of drivers, and thus leading also to more risky driving behavior. Those vehicles are heavier due to the presence of batteries, and we know that in case of accidents, a heavier vehicle means a lower risk for the occupant, but a much higher risk for other users involved in the accidents. There are some risk of fires with batteries which are very difficult to extinguish. And there are also risks for vulnerable users, particularly for pedestrians, cyclists, and visually impaired people due to the low noise emission of such vehicles. So there are a lot of things which must be studied and solved in order to reduce and eliminate possible negative impacts of electric mobility on road safety. Connected and autonomous vehicles. So many people think that once we will have all level 5 vehicles circulating on our road networks, road accidents will disappear, as well as injuries and fatalities. This is due to the idea that nearly 100% of accidents are determined by a wrong behavior of users. So once users will no longer control the vehicles, and the vehicles will work automatically, the contribution of users in accidents will disappear, thus leading to a complete safety system. This is unfortunately not completely true, because there are several aspects affecting also the introduction of autonomous vehicles. First of all, the need for significant investments to prepare the infrastructure, the conflict between the community and user objectives. Once we will not have the possibility to control the speed of our vehicle, which speed will be adopted? So if we look at the community objectives, we should adopt very low speed, while users don't want to travel at a very low speed. Risk of crimes for shared vehicles, and risk of failures and hacking for systems controlling the automated vehicles. They can lead also to an increased amount of travel, since they will give the possibility to use cars also to people not currently using them, and for And for lower level of automation, we can have an increased risky driving behavior, more aggressive and distracted, and less cautious for also for highest automation levels, for instance, the use of safety belts. Moreover, they are expected to be fully integrated in our mobility systems still in some decades. So if you look at the literature, there are different forecastings about the market penetration of autonomous vehicles, but we are sure that they will not constitute the full fleet of vehicles before some decades. Shared mobility. Shared mobility in many cases means also a higher use of high risky modes like bike sharing and e-scooter sharing. Users using shared vehicles very rarely have a low driving experience, and we all know the strict relationship existing between the driving experience and the risk of accidents. In some cases, vehicles can be not equipped with protective tools like child seats, for instance, or there can be the lack of equipment like windscreen washer fluid or warning triangle on the vehicles. There is the big problem of vehicles which are abandoned everywhere on the street, on the sidewalks, and moreover, they often tend to be not so cautious when driving due to the fact that those vehicles are paid according to the time of use. This is to say that there are several worries, but probably those worries disappear when we come to digitalization. Digitalization is really providing incredible improvements to road safety analysis and management. So very rapidly, because I see the time going by, in the current situation, we improved significantly the way we can collect and analyze data through digitalized systems, the way we collect the data on traffic through floating car data, to smartphone data, coming from GPS or coming to the connection of smartphones to the grid of cells, allowing us to have available a lot of and high quality information on trips in terms of origin destination matrices. We can use digitalized system to collect the data on the infrastructures through video inspections conducted using different level of equipments for special vehicles. And another element we are working at the moment on behalf of the United Nations for the African continent is the collection of data on infrastructure using satellite imagery and artificial intelligence, which is something probably not needed for our countries where we can have a good control of our infrastructures, but in areas like the African low medium income countries, like the African countries, this is a powerful source of information for monitoring the quality of infrastructure. And in the short term, still now and even more in the short term, we are developing the tools to predict the accidents using images collected at specific locations and using again artificial intelligence algorithm to identify the conflicts of vehicles. Identifying conflicts means to predict the possibility of accidents, so intervening on the infrastructure and on the traffic management before accidents occur. And the same for real-time traffic management based on risk prediction, which means to collect a lot of online information on traffic volumes, speed, traffic density, weather conditions, other kind of sensors, even information coming from the users, and all those information can be included as input variable in functions allowing to estimate the real-time risk in different parts of infrastructure and intervening in order to reduce the level of risk through different means like variable speed limits, onboard information, control in the number of vehicles through ramp metering, modification of the traffic signal settings in order to reduce the level of risk on some parts of the network, dynamic message signs, and so on. So nowadays, the way those information on the traffic risk can be used to reduce the risk is very large. The different approaches can have different potential. So in terms of timing, of course, the approach based on accidents is the worst one because we have to wait for the accident to occur before we have the information, while the online traffic management is the best one, able to work online and to reduce the probability of accidents some minutes before they can happen. In terms of data availability, we have problems for a lot of cases. In terms of extent, we can use the accident data for all the network, while the image-based is just for some location. In terms of regulation, we have problems every time we have to collect data on specific locations using cameras or drones. We have to request a lot of authorizations. It's not an easy problem. So this is to say that we need an integrated approach. We cannot think that a single element can improve all the situation. And we cannot think that the technology itself will improve the situation. So we always must bear in mind that we need an integrated approach. Technology is crucial, as we have seen, can also lead some problems, but everything has to be integrated in a comprehensive approach to planning. And it is an example, the 30 kilometers approach, which is being adopted in a lot of cities in Europe, which is leading to significant results. So technology, safe system principle, and in general terms, the need for an integrated and comprehensive planning through dedicated tools like the sustainable urban mobility plans, always bearing in mind that the strong relationship between the land use and transport. So I think this is particularly relevant for the Ukrainian cities. Hopefully very soon after the war, a lot of new planning also of land use will be needed, and we always have to remember how a correct land use planning affects the sustainability of transport systems. Thank you for your attention.
Dear Luca, thank you. If we have question, please switch on the microphone and ask the question.
I'd like one question.
Okay, please.
Good morning, dear Professor Luca PERSIA. We're very happy to see you. Thank you very much for a very interesting report. I have a question which I'm sure are really interested for Ukraine now. What strategies or practical plan, roadmap would you recommend to increase the resilience and adaptability, flexibility of transport systems in contexts of urban mobility in the condition of war or heavy crisis? For example, for Ukraine. Thank you.
Well, of course, your question is not an easy question. It's a very difficult question. I can say that according to the experience we lived during the pandemic, when we had to face a completely new situation, and so the word you used, the resilience, was the word that everyone was using. We have to improve the resilience of transport systems. So, which was something during the pandemic, everyone was very active in trying to improve the resilience, even if once the pandemic was finished, the equilibrium of the transport systems unfortunately got back to the previous situation. So improving the resilience to me means improving the sustainability. We saw in a couple of pictures how unsustainable are the current transport systems, even because they are close to the capacity and in many cases also over the capacity of the road networks. So until when the transport systems will be based on the use of cars, in my mind, their resilience will be very low. In order to have more resilient transport systems, they must be more sustainable. They must be more based on public transport and on green modes. So promoting walking, cycling, and other sustainable modes. And in this view, I arrived to the last slide I showed, the importance of land use planning. We cannot have sustainable and resilient transport systems if our land use configuration is not appropriate, which means low density, mainly in terms of density. If we compare the characteristics of transport systems, for instance, in North America or Australia, they have very low density situations and so fully car-oriented transport systems, always struggling with congestion and building new infrastructure and so on. So the idea is that there must be a strong coordination at regional level for a correct land use planning, because the land use planning is something which cannot be done itself by a single city. People are free to move from one city to another, from the city center to the country and so on. So to me, the basic will be a correct and appropriate land use planning for the rebuilding of parts of cities and so to the new configuration of the Ukrainian cities. And as a consequence, having planning a sustainable transport systems focused and based on public transport and other modes, because until when the systems will be based on cars, they will not be resilient.
Okay, thank you very much. Any other questions, please?
Can I ask a question, please?
Okay, let me.
Yeah.
Sorry. One moment.
Thank you, Luca PERSIA, for very interesting presentation and information provided. We are from Zhytomyr State Polytechnic University, a member of Smart Transport. So thank you for that interest for CO2, for that accent for military impact for CO2 that probably help Europe to understand just that huge impact really, and in this year that more even that 2022. And my question is connected to your research that you provided in slide 10. I think this is about safety of electrical vehicle, because we work a little bit with the safety of hydrogen vehicles that consider like electrical as well. And at the moment we have some research continue to that. Is it any step in this fuel cell hydrogen vehicle at your university? I know that Italy is very just to support that hydrogen industry, and so my question about safety of hydrogen fuel cell vehicle. We have that even Toyota Mirai in our university that deliver for us is that hydrogen Ukraine. So just thank you.
Well, I must say that I must confess that I'm not directly involved in research on hydrogen vehicles. There are colleagues of mine who are working hardly in this field. If you like, I can put you in touch with them. Anyway, for sure, the attention of hydrogen use in transport is having a strong increase in this moment, especially due to the doubts which are arising on the electric mobility. As you know, there has been for years a very strong direction towards the substitution of internal combustion engine vehicles with electric vehicles. But nowadays there are some doubts in the sense that the acceptance of users for those vehicles is being lower than expected due to several reasons and so on. So this is producing again a strong interest in hydrogen vehicles, which to me will have a future much bigger than expected. So for sure, they can present some safety issues, but I suppose that I'm sure that the research on this kind of vehicles will grow its importance in the near future. So we will be more than happy to cooperate with you if you like.
Thank you so much. Hope we will collaborate again in new area and continue to collaborate in that.
Great.
Yeah. Thank you so much.
Thank you. Thank you very much, Luca, for your presentation. Very interesting topic.